Today is the third EATS presentation at Phase A. Today we're going to be talking about SCR SRR Expectations. My name is Emmy Coleman. You guys probably met me at kickoff. I'm the Junior Systems Engineer here at the UNP office. So let's just get right into it. SCR is the Systems Concept Review. It'll be a virtual presentation on your overall mission concept and experiment plan. And then it'll be a 4-hour presentation roughly, where the first 45 minutes is your presentation. The rest of the time will be discussion with reviewers from UNP, SSP, and AFRL. Potential topics of discussion at SCR, we're mainly looking for high-level mission related. Since this is the first review in Phase A, we're not going to get deep into components, hardware, all of that sort of stuff. This is pretty high level. So some examples would be, what experiment are you conducting in space? Is this realistic to do in space? Is this even relevant? Is there value in this? Why do we need to do this in space? Those types of things that we'll be discussing. And then what we're looking for is good understanding of those high level things. So science objectives, concept development, experiment plan. Obviously, ultimately, the goal is to have a mission concept that has a clear understanding of how it's going to be accomplished. The expectation. This was talked about a couple EATs ago, but just to review, the mission design document, it will be the focus of SCR, and it has 3 main topics within that: the mission overview, the experiment plan, and the ConOps. So the mission overview is a high-level intro to the mission objectives, mission statement, success criteria, military relevance, that sort of stuff. The experiment plan addresses what experiment or experiments the satellite will perform. So it's not the step-by-step procedure, but rather like, hey, it'll do capture images or something. Where the ConOps is the step-by-step procedure, the timeline of what the spacecraft will do in space, and it describes the modes of the system. So you've heard terms like safe mode, science mode, comm mode. And then in this presentation, the user's guide references will be italicized. So if you want to refer mission design document, it'll be 8.2.4. So the deliverables for SCR will be the mission design documents, the schedule. So think of this kind of like a Gantt chart. This is more for you guys than for us, but it is good to have a document in writing that says, these are our tasks. This is when we need to do these tasks. So a good example for this deliverable is, okay, what tasks need to be done in preparation for SRR, that sort of stuff. Timeline, schedule, all that stuff. PowerPoint presentation, obviously, you guys are going to be presenting to us. There is a template in VDL that goes into this stuff. I mean, everything that we just talked about in the past slides, it's in there too. And then another deliverable that's recommended, it's not required, is the protection plan. And this will be an initial draft, like nothing too in depth, but basically what we're kind of looking for is, what plan do you guys have in place to protect sensitive information? So like the distribution, government stuff, ITAR policies, all that stuff. What plans are in place so that it's not just publicly accessed? These deliverables are due a week before your scheduled SCR, and then the submission will be through VDL. So you guys aren't going to be emailing it to us. You'll be putting it in your folder in VDL. If your university doesn't have access to VDL, we can talk about it at the end of this, make accommodations if need be. For the most part, through Phase A, Phase B, all of that stuff, submissions will be through VDL. Do we have any questions on SCR? I know I kind of went quickly, and I can go back to any other slides if need be, but any initial questions?
About the protection plan, how high level and what level of detail are you wanting in this?
In the user's guide, it starts to talk about like encryption and like software protection. From my understanding, what we're looking for is, what things do you have in place in order to protect distribution D, distribution C information? When I went through UNP,
I'm not sure what happened over there, but Emmy, if you can hear us, you cut out. I will continue answering that question. The other piece of that is, a lot of students, of course, are not very familiar with distribution limited information and the concerns surrounding it. I would say a big piece of it is a way to educate students and help them understand what what those concerns are surrounding distribution limited information. The other piece is not just distro limited information, but also how are you handling operating your satellite? Is there encryption that you have to take care of? Other information and hardware security pieces. So I'd say one of the most critical pieces though is just the educational aspects, because I think students have never had any exposure to handling of distribution limited information, and it is new to them, and they'll need to understand what is allowed and what isn't.
Yeah, sorry about that. So SRR is the System Requirements Review. It's a more in-depth discussion on Zoom, again, remote, of the flow down of requirements from the mission objectives. We're not providing a template, no presentation is necessary, but if you guys want make presentation material, have at it. It's not a requirement. SRR, what are we looking for? Basically, it's taking the mission statement, mission objectives, the mission design documents, everything that you created in SCR, and then flowing it down to the system requirements and the subsystem requirements. So to read that bullet point, understand how subsystems support the higher level requirements and mission objectives, and a clear path to verifying those requirements. So obviously the definition of a requirement is pretty easy to understand. We want it to express clear needs of the satellite for it to achieve its mission. So it must be verifiable, quantifiable. It's good to know and to have a frame of reference that requirements are an iterative process. So when you write your RVM, it's not a one and done type of thing. We'll iterate on this, and maybe during the SRR, some of your requirements might get totally hashed through, but you can refer to 2.1.2 requirements development for this process. And then also the EATS next week will go more into detail of like writing requirements specifically. So the RVM, which is the requirement verification matrix, will be the main focus of this review. And the reason for this is because requirements will drive your entire design. And I would even say that this RVM is the primary tool of this chief engineer, just because it shows, hey, are there any requirements that we're like lacking on verifying? How is the team doing with verifying these requirements, that sort of stuff. The focus is on mission specific requirements, how it flows down from the mission objective, mission statement. Why are you guys doing these requirements? And then how are we verifying it? So UMP levies requirements on you guys, and that's in chapter 7. And these should be included in the RVM, but it's not the main focus of SRR. If you guys have any questions or concerns about what we have in the user's guide, we can address it at SRR for sure, but it's not going to be the focus. And then include and address relevant constraints as well. So we kind of talked about this at kickoff between like a requirement versus a constraint, but you can think of a constraint as programmatic. So like we only have X amount of students or X amount of funding. Mission, so like if you have a ground station that you can use, but it only does UHF, that's a constraint. Hardware constraints, I can only buy this much because I can't buy like $1 million part type of thing, or even form factors. So you're constrained to 2E3 or that sort of stuff. And then that reference has more details on deliverable expectations. So here's an example of some requirements, like an RVM example in this table. So COM would be a subsystem requirement, and then 1 would designate the first requirement. There's the requirement, I'm not going to read it, but then the source, this is actually a UMP levied requirement. And then verification method would be inspection. It's currently incomplete, and it will be verified in this document. So that's an example of how I guess a UMP levy requirement would look in an RVM. But then the second one could relate to your mission, it doesn't have to, but ADCS1, the first requirement in the ADCS subsystem, the satellite shall be capable of 3-axis stabilization, and that came from the second mission objective, so MO2. And it'll be verified through analyses, currently incomplete, all that sort of stuff. So that's kind of how it typically looks. How do science requirements trickle down through the RVM? Here's a simple example. This was stated in the user's guide, but I think it's good to go over. So a simplified mission statement could say something like, we want to have a better understanding of atmospheric density. How can this even be done? So probably through some hardware component, potentially through a neutral mass spectrometer. You investigate the spectrometer and you find that to fully characterize the atmosphere, you calculate that data needs to be collected for at least 100 orbits within 400 to 500 kilometers. Through this process of investigating and, flowing down and kind of becoming more specific or whatever, you find that orbit lifetime and preferred altitude have been determined. So requirements could be made from that. So this is just a simple example of that. The mission design course that you guys did at kickoff kind of went through this, where some of the teams were like, oh, we need to do at least 10 orbits or at least this many passes a day in order to get this data. So kind of that same process, systems engineering process. Here's a more technical example. So Polar Cube was an actual satellite that went up. This is a real thing. This isn't like a fake mission that what you guys saw at mission design course. This was like a real thing. The mission statement, I can read it. To perform high spatial resolution, cloud penetrating tropospheric temperature sounding and observation of sea ice open ocean boundaries, and in doing so, provide representative data inputs to tropospheric weather models applicable to several mesoscale weather and hurricane forecasting. I'm gonna be honest, the first time I read this, I was like, what? So this is a little technical, but I wanted to have this in here for your guys' reference of, okay, this was an actual mission with an mission statement, all that stuff, and this is how it flowed down. So I'm not gonna read the whole slide just because most of it I can't really speak on. I don't really understand most of this. Basically, the mission statement says, okay, we need high resolution. What kind of components do we need to do that? That's going to influence data, that's going to influence pointing, that's going to influence where we are. We need to know where we are. Just that whole flow down process is what I'm trying to get at for your reference. That influences the instrument that you even need and the subsystem level requirements. So these first two ADCS requirements were in the mission or in their RVM or whatever. The last two were just examples of over constraining yourself, over complicating things. So for the third one, it says point within 0.1 of a degree. That'll be a little too complicated. So a question that we could ask is, can we get away with a lesser accuracy? And if we could do a lesser accuracy, that would not complicate the power budget as much. The fourth one is actually a conflicting requirement. So if you read the first one, it says, hey, point this axis in this direction. And then the third one says, hey, point this axis in this direction. The fourth one is actually over constraining because we need to point in all three axes in a certain direction, which is like not possible. Just keep in mind that while writing requirements obviously is good, we want to make sure overcomplicating or over-constraining ourselves. The deliverables for SRR mission design document, again, if there's any updates that need to be done from SCR, do it here. Schedule RVM, which will be the main focus of this review. Protection plan. And then the new one in this review would be the software design document. So this will be a pretty short, high-level explanation of how you plan to develop your software. So how do you want to structure the software architecture and the CDH architecture, or even the team? What development method will you go with, type of thing, or options? What tools and trainings are needed? These are due a week before your scheduled SRR through VDL as well. That was the portion of SRR. Do you guys have any initial questions?
If anyone has any questions on SCR, SRR, anything else, now is your chance. This was intentionally somewhat short to provide time for feedback, questions, things like that.
Any last questions?
With regards to, I guess, writing out the mission objectives and the minimum success criteria, we have the ones from NS10. They got to a place where they were okay, but we kind of reevaluated what we're actually doing and versus how we're going to essentially meet those minimum success criteria. And so we haven't really changed anything about the experiment that we're going to run, but just kind of how we're going to determine those minimum success criteria.
Tie the requirements verification and everything back to like a experiment plan flow or ConOps flow, where you effectively don't have to capture everything word for word in the RVM, because the RVM will probably be designed, you'll design to meet your full success criteria, right? And then so if you set that at a sensible place, then you could come up with some sort of table or flow diagram that says, here is the path we're going to take through all the experiments step by step. And you could kind of point back from the RVM to that document or whatever and say, here's why we defined these things the way we did, because they make sense and they are meaningful in terms of this experiment flow. Does that help?
Yeah, so I think I understand. So would it be okay essentially to say, have like, I don't know, 3 or 4 mission objectives on the RVM and have them almost just say the satellite shall meet section 3.2 of the mission design document or something like that? And would that be okay? Or would you want something more specific, I guess?
I would say try to have the mission objectives be clear and then have the document provide more background if necessary, or the document can provide maybe the justification. But I would probably avoid having the objective, I would want it to have its own language probably, and then just more explanation, more justification can show up in the document would be my recommendation.
Okay.
Hey, Jesse, can you hear me?
Yep.
I just wanted to take part in your weekly meetings this week. I know Georgia Tech's on a different schedule than everybody else, but I'm just making sure we're not expected to do an SSR, just the
No.
design. Okay.
No, so this one was specifically tuned towards the other 10 schools. We will actually be sending you more information on the TI1, the first design review soon.
Perfect. Okay, yeah. I'm about to respond to Beth's email right now. I just wanted to make sure that I wasn't speaking out of context and make sure I didn't have to prepare for this as well. So thank you so much.
Certainly, tracking requirements and things is something I want to do, but at the mission level, it'll flow more from the mission that you were provided, less from a mission you come up with and objectives you come up with.
Perfect. Well, thank you guys for your time. It's been a pleasure. It was a good presentation. So